Hey guys, and welcome to another special video driven by the release of information finally about IOTA's QUBIC today. Normal content for this channel is always on a Tuesday, which is aimed at insight into the future of the blockchain and some opinion pieces around that. Today, however, and following on from the tradition of the EOS launch video on Friday, I want to bring you new announcements as they happen. I would really appreciate it if you could subscribe to this channel and like this video if it hits your buttons. It lets other people know that it's good and gives me some motivation as well, so it's much appreciated. But let's get into it, and starting with a quick background of IOTA. For those of you around the periphery of blockchain tech, it's difficult to know much about the non-mainstream tech. Everyone is mostly focused on Ethereum, Bitcoin, Hyperledger. That's the stuff that's in the news. However, they are not the only interesting decentralization tech by far, and some lesser known blockchain technology stuff are still doing some amazing things. To demonstrate the importance of these other technologies to the market, one should look at the capitalization of the coin, and IOTA is no different. Its coin is the MIOTA. It's roughly about 5 billion in market cap. Contextually, EOS has about 13 billion, Ethereum 61. So IOTA is roughly about the same size as Stellar and Cardano, and with Litecoin a little bit more. But before we get started, although white papers exist for IOTA, the QUBIC white paper is still under internal review, so I'll share my thoughts on the published information, but I will come back to this once I can dig into the maths, once I actually see the document itself. Hold everything with a pinch of salt until we can independently validate these claims. Now, IOTA was initially created in 2014 to solve the problem of how micro devices communicate and share data between each other. IOTA is therefore meant for the Internet of Things, really, and the clue is in the name, IOTA. It runs on what is known as a DAG, or Directed Acyclical Graph, which is a new type of data storage solution. A graph is a series of nodes connected to each other, and acyclical means that the nodes only communicate one way. There are no cycles. It's kind of like a visualization of a backpropagation neural net, if you've ever seen one of those, or a bunch of dots connected together going one particular way if you haven't. We can kill two birds with one stone here and explain why directed acyclical graphs for DAGs are so quick, and also what is a tangle. A directed acyclical graph is, in the case of IOTA, is a transaction which points to multiple other previous transactions, and they in turn point to transactions and so on, all the way to the beginning of the DAG. In that way, it's similar to how a block is blockchained, and it points to a previous block all the way back to the genesis. But a DAG is more of a block graph, with the block being a single transaction in this case. Now, the IOTA tangle is basically IOTA's name for a DAG. I should give it a bit more detail. When making a transaction, you sign your transaction with your private key, and two other transactions are randomly selected, which your transaction will reference through a Markov chain Monte Carlo algorithm, basically a probabilistic function. Transactions gets confirmed when your transaction is referenced from someone else's transaction, and this is how the chain of transactions gets built. It's also where the smarts for this technology come in as well. If your transaction requires you to verify previous transactions, then no miners are required, hence no transaction fees. It's also inherently scalable. As more people join IOTA and submit transactions, they also verify two other transactions, meaning that for every new user, there is also a new validator which is doing enough work to pay for its transactions, but also a second transaction, making IOTA even faster. That is a pretty cool way of scaling. Now, IOTA is not without some issues, and the first being centralization. Decentralization is kind of a big thing in the new world. It improves the hardiness of the systems and allows scale to occur. IOTA centralizes through the use of a coordinator node, which initially validates transactions. The coordinator node is a single node owned by IOTA and is validating the early transactions, which kind of suck for decentralization. However, IOTA happen to have been very clear about this, and it's in the white paper, so they're not trying to con anyone about anything. There are other few things that you need to question as well about IOTA, particularly about the size of its DAG and subject to 51% attacks. Like all emerging systems, there have been some technical issues as well, that's particularly around the desktop wallet. However, they seem to have solved that, and a full security audit happened in April, last April, a month ago, and now that wallet is being ported to the desktop. But importantly, there was a new announcement yesterday, and the reason IOTA is in the spotlight again is they've been teasing us with the IOTA Q project for some time. A few hours ago, they actually started to explain what it is, and basically Q is something they call quorum-based computing. It revolves around something called a QUBIC. Now, what is a QUBIC? A QUBIC is essentially a prepackaged computational task. It's kind of like a smart contract, but it's not aimed at parties transacting or collaborating together. It's more purposeful than that. QUBICs are written in a functional language called ABRA, and the functional aspect of it is very interesting because it allows computers to validate the correctness of code and its output easier, which seems to be a bit of a thing this year, particularly with things like Cardano. The language is also trinary instead of binary, which is cool. In the classical sense, binary means that each digit can represent 0 or 1, trinary is 0, 1 and 2, but details are lacking at the moment about how far along the line and what the impact of that is, thanks to no white paper. We'll see that in maybe a few weeks. It may sound random, but given IOTA is aimed at IoT, we're talking physical devices, and energy consumption of physical devices can be reduced if these boards are able to handle trinary style code. I need to dig in more about the physical aspects of IoT. I'm not a specialist in that area, particularly energy management, so let's hold this space. ABRA is also an intermediary language, so we can expect other types of languages, maybe a JavaScript or a functional derivation of that, to appear very soon. QUBICs are event-driven and they live on the IOTA tangle, deployed by transactions, and they link together as well. They can pass outputs from one qubit to another QUBIC, and because of this, QUBICs can form kind of chain reactions that escalate through the IOTA DAG, which I think is some nice imagery. In some ways, these could be called true cloud computing, but the execution of them is very, very different. It's more around a decentralization issue. Now, qubits have themselves some issues. The big one of this, of course, is qubits are not in infinite loops. They're not Turing complete. One of the functions of IOTA QUBICs is that their processing take place in period times. They call them epochs or epochs. It looks like this restriction is there to control abuse of the system by limiting processing. But why is that important? Why is Turing completeness important? It means essentially that ABRA can't represent all types of scenarios through its programming language. The energy consideration nature of the QUBIC may force it to be limited to IoT-style processing, but that is not a bad thing. Pick a target, hit it, that's a winning strategy to me. However, it is suggested that if you have enough processing cycles, then you could probably get something close to Turing completeness, but let's wait and see. Now, what is an oracle? An oracle is an integral part of QUBIC. An oracle is a link to an outside of the tangle which provides accurate data from the real world, such as temperature sensors or stock market price on a specific date. The other part of this is an outsourced computation. You can also connect your QUBIC to an external processing machine called an outsourced computation, and this outsourced computation are basically processing that receives data and sends back a result. If a device such as an IoT sensor can't handle the load of what it's trying to do currently, it can offload it and get a result from a more powerful machine. Now, what is a quorum? And this leads us to the final part of the puzzle, and it is to ask what a quorum is then. So a quorum is aimed at both Oracle machines and outsourced computations. It is not a data storage solution, but instead tries to confirm the outcome of a transaction, of a computation rather. And it does this by asking the same thing of many Oracle machines or outsourced computations. When you post a QUBIC contained in a transaction on the tangle DAG, you can execute it and you can receive one result from an oracle, but how do you actually trust it? Well, you don't, unless you own the oracle. You need to check lots of oracles, known as assembly of oracles, and get an agreed result between all of them, a quorum. The more reward the QUBIC owner offers to share between a larger number of oracle machines, the more of an incentive the oracles have to behave as a good actor, because they need to agree on an answer to get paid. If they don't agree, they don't get paid. And a QUBIC requires around, I think, 2/3 of the oracle machines agreeing with them, agreeing with each other. In blockchain networks, this is actually quite similar, that you need a number of validating nodes to agree a block. But the difference here is that the QUBIC owner is making a choice about how much confidence they need in the answer. And that looks like to be the key differentiator between IOTA and blockchains, or QUBIC and blockchains. Basically, IOTA QUBIC enables you to decide how much confidence you want in an answer based on the latency you're willing to suffer through waiting and the fee you're willing to spend. It's very similar to paying for a transaction on a blockchain, but instead of doing this as a transaction level, you'll do it at a QUBIC or a smart contract level. Interesting. So, to wrap this up, IOTA is not a blockchain, but it's a directed acyclical graph called a tangle which stores data. it is extremely fast and gets faster with each node that submits a transaction, because that node then needs to validate 2 other transactions for each one that it submits. It's a nice way of turning wasteful mining machines into useful data processors. Now, QUBIC is a way of executing code on the Tangle, similar to smart contracts, but kind of aimed at IoT. Those making money from QUBIC will be providing oracles and outsourced computation computers, which will do the extended processing required by the QUBIC code itself. They operate in multiples called assemblies for oracles, and you can decide how accurate you want outputs to be by selecting large assemblies and paying more money to perform those transactions. The output of those groups of processes is called a quorum, because multiple machines need to agree to give the same result. This is all great stuff, and I can't wait to see where this goes next, but we do definitely need the white paper on some of this. Now, if you liked, please subscribe. It helps other people find this content and rewards me in terms of getting noticed. I really do appreciate it. Take care, and I'll see you later, probably tomorrow, but with more opinion pieces than investigation into a technology, and I'll see you soon. See you later.